it. So it likewise would have a Q bar. And I'm going to call this N here, because this guy is going to be clocked. It can only change state on a particular edge or level of a clock signal. So our gate is going to look like this: a J and a K, and then it's going to have a clock. And here's going to be our Q and our Q bar. So the JK flip-flop can only change state on something on our clock. So let's go with a clock like this. And I'm going to say that it can only change states on the falling edge. Okay. So when this happens, when I get a falling edge, the Q is going to be my QN. So this is going to be N, this would be N plus 1, this would be N plus 2, and the falling edge I had over here would be what? N minus 1. That was difficult, okay? Everybody all right so far? Okay. So let's take a look at this thing. You go 0, 0, 0, 1, 1, 0, 1, 1. Okay. For 0, 0, I get out Qn plus Qn minus 1. In other words, if both, so, well, we'll keep going through here. Okay, if I put a 0, 1 in, at the Qn spot, I get 0 out. If J is a 1, K is a 0, I clock it, I get a 1 out. Let's stop there for a minute. What does J correspond to in what I've done over here with this guy? No. Close. S. You see that this guy looks like our old S, right? What do you suppose the K looks like? Looks like R. Okay. What was the problem with our set reset flip-flop though? We had an illegal state in there. We fixed that with the JK by saying if I get a 1 and a 1 and I get a clock, my QN goes to the opposite of what the previous one was. In other words, it toggles. Everybody all right with that? I can't. I can. Yeah, I can narrow it.
I guess I'm not seeing how we're determining the Q n minus 1 part and the Q bar n minus 1.
It's what it was before the clocking event happened. Okay, so let me give you a waveform here. Okay, so here's my clock. Here's my J. Here's my K. Looks like an awful lot of junk going on, right? All you have to do is look at it just a nanosecond before the clocking event. So where's my clocking event here? Right there. I'm saying that it's clocked on the falling edge. Right at this time here, just before, And I better give a Q here. Let's let the Q up to this point here be 0. Is that all right? Right at this clocking event, what's my J? What's my K? What does my table tell me to do?
Q and minus 1 bar.
It toggles it, right? So what was the Q? 0. What's it now going to go to? 1. How long will it stay a 1?
Until it gets new.
At least until the next clocking event. So our next clocking event is over here. We don't know whether it's going to stay a 1 or stay a 1 or go to a 0 at that. But we can always take it over to the next clocking event time. Yes? All right? Don't have to do anything else until we see what's going on at the next clocking event. That happens here. Right here, just a little before it, what's my J? What's my K? Where are we at here? A, B, C, or D? B. Right? What does it say it's going to do? It's going to take my Qn plus, it's going to take my Qn and do what with it? Take it to a 0. So this guy is going to come down and is going to stay a 0 until the next clocking event, and then we're going to figure out what we're going to do with it. Everybody okay so far? Now, on your own, tell me what's going to happen next. Okay, you're looking just right here, correct? Figure out what J is, what K is, what the Q is. Everybody agree? Okay. J's a what? 1. K's a 0. So that says take this guy up to a 1. Everybody all right with that? Okay. So now what happens? You're going to look just a little before the clocking event. My clocking event is right here. What's the J? What's the K? What's it going to do? Stay at 1.
Dr. O'Brien, so why are we doing it before? Why aren't we doing it on the line? What was that significance? Was there no significance in like the arrows?
The significance of the arrow is telling you that this is falling edge trigger.
Oh, okay. I see they're aligned, so they're falling or at that level.
This is the clock.
On this
It's a
side.
square wave.
Okay.
Okay, I could have rising edge triggering. I could have level triggering. Most of these are edge triggering. It helps us out. Everybody all right? Yeah.
Why is it labeled as Q to the n minus 1? Like, it stays the same, but why wouldn't it just be a 1 again?
Are you at this stage here?
Yes.
It is a 1.
Yes, I understand what I'm saying. In the table, it's labeled as Q to the bar over Q to the n minus 1. Like, why wouldn't we label it as 1 again?
It is. Look, at this point here, what's the J? What's the J?
1,
Okay, what's the K?
0.
That's here, correct? It says this guy is 1.
I was looking at
You okay? You all right with the
Mhm.
where we're at now? Yeah.
So is that truth table determined beforehand, or is that?
This is functioning table. Okay. So again, what have I made? I made a 1-cell memory, and if I want to, I can do some toggling. Yes? Okay.
is the n and the n minus 1 and the plus 1 and the n plus 2, is that kind of arbitrarily assigned? Like, why wouldn't you have your first clocking event at n and just go up from there? Like, why an n minus 1?
Well, would you have preferred if I did this?
Yeah, that's like, is it arbitrary, or is that like a rule of thumb? Okay.
Yeah, I mean, you can, n is n. You can make n
Okay.
100 or minus 1, or yeah, you can call it whatever you want to. So we could call this n, this would be n plus 1, n plus 2, n plus 3.
Okay.
Question?
So on the right there where you have the values for the Q sub n, are those the values for both Q sub n and Q bar?
No, what do you expect Q bar is
The
going to
opposite,
be?
yeah.
Exactly. So right here, this is going to be what? If I finish filling in the table, this is going to be Q n minus 1 bar. This is going to be 1, next one 0, and here Qn minus 1.
Did we determine these values based off of the inputs, or did you just assign these values?
No, these are absolutes.
Okay,
But somebody's got to give you a waveform here as to what's going on with the J and the K.
okay.
So why do you suppose we're clocking this thing? Because there is feedback, and we don't want to have race conditions where you saw up here with my set reset flip-flop, just the kind of individual cross-coupled NAND gates, that the outputs are feeding back to the input. Well, you can get situations where one gate might be slower than the next gate and can screw things up when you're taking outputs back to the input. So we like to clock things so that things happen on very precise times, and we don't have to worry about time delays, etc.
And you said that's called rates conditions?
Race condition is where you've got outputs feeding back to inputs, and because of slowness and time delays, it can screw things up. Is that all right? Okay. Okay, what have you noticed I've done here? How many JKs?
2.
2. What are the inputs to the second one? The outputs from the first one, right? Okay. So do you understand here that I'm going to have to come up with my clocking signal? And again, you can buy these things so that they're clocked on the rising edge. You can buy them so that they're clocked on the following edge. Which do you want me to do? Okay, just for something different, we'll say it's clocked on the rising edge. So I'm going to put my arrow on every rising edge, and that's going to be where my triggering event is going to happen, and we have to see what's going on just before that edge. So I'm going to put my A and my B. Here is Q0 and here is Q1, and I'm going to say that the Q0 Q0 and the Q1 are both at the first zeros. Okay, so let's come up with some arbitrary waveform here. And I apologize, it's easier for me to draw it than it is for you to reproduce it. But okay, figure out what's going on with the Q0 and the Q1. Looks daunting, yes? It's not. Before each triggering event, figure out what the inputs are for each one of them. You notice that the clock goes exactly the same to each one of those, correct? At least get the first couple lines done, and then we'll start there. Okay, everybody's transcribed now? Okay. At the very first clocking event, what's A? 0. What's B? 1. So what's going to happen? Now that's not the 1-1 state, isn't it? So we're not going to get any toggles. Something's going to change on Q. Q0. Is it going to set it or reset it?
7.
The J is a 0, the K is a 1. That does what? It resets it. Means that our Q is going to go to a 0. But it is what? It's already a 0, correct? So it just stays there. Okay, it stays at a 0. What are the inputs for the next one? What's its J? It's 0, right? Remember, its J is 0, and what's its K? 1. So what does a 0, 1 into a JK give you? Gives you Q of 0. So what was my Q1? It was 0, so it does what? Stays a 0. Nothing exciting going on here. Okay, and we transpose that all the way out to the next clock event. Nothing can happen until it's clocked. Now, take a look at the next time period right here. What is the J of the first one? 1, correct? Anybody not see that? This J during this clock event is a 1. What's the K?
0.
So what's going to happen to my Q0? It's set, right? So it's going to go to a 1. How long will it stay a 1? At least until the next clocking event. And then we got to figure out what's going on. Okay? What about the Q1? Yeah, question.
I think this is just the only thing tripping me up from not seeing this. But why didn't it get reset to a 1 in the first clocking period when it was a 0?
Because the input was 0, 1. Oh, 1, that's 0, 1. 0, 1 says reset it. Take it to a 0. Already was a 0, it just stays a 0.
Okay.
Okay. All right, what are the inputs during, right at this time here, what are the inputs of J and K for the next flip-flop?